So it's through a different website. Like it's not through.
Yeah, it's AP. No, it's not AP.
Yeah, it's not like through the
AP
AP.
class, whatever.
No,
Uh,
it's like a completely different website.
because
And Desme
my
just can't remember his login. He's like, I keep logging in with
because like
Google.
my AP class.
Oh yeah, yeah, it's not that one. All
Yeah,
right.
my AP classroom is like when you log in some days.
Okie dokie. Come on. So, Kadeem, it was you that was asking about the one with acceleration due to gravity. That was you, right? I think it was. Okay. So, when we solve these problems, oopsies. Button. There we go. All right. So, when we solve these problems, what's the very first thing that you do? What's the first step? You all hear me? Test, test, test. One, two. Why'd everybody go quiet? Well, so Brian, before that, we read through the problem and we understand what's going on. So, how long would it take a car to go a distance of 528 meters if it was initially traveling at 15 meters per second and was accelerating at 1 meter per second squared? Cool. So, what is it asking?
348.
What, Stuart?
348 seconds.
So, what is it asking us to find? Anybody other than
Yeah.
Stuart?
Okay.
It was asking how long would it take for the car to travel a distance? Yeah. So, it is going to be time. So, t equals, and that's going to be in seconds. Cool. So the next step is we write down what we know. So it says, how long would it take a car to go a distance of 528 meters? So 528 meters. And that's going to be the distance. Then it says if it was initially traveling at 15 meters per second. So 15 meters per second. And traveling initially, and I have units of meters per second. Which one of these variables is it?
VI.
Yep, v sub I, so the initial velocity. And then it was accelerating at 1 meter per second squared. So that one should be pretty easy. So
D.
1
Okay.
meter per second squared. So that's going to be the acceleration. All right, is there any confusion so far? So we wrote down what we need to find, which is the time, and we got down the three knowns. Now, if we look at the problem, yes, Chad.
I don't know. I did. I don't know. I just want to see what it was doing.
Oh, okay. I just want
I'm
to see.
sorry.
I wanted to push a button. Okay. Is that Stuart? Ah, no, that was my fiance. Stuart, I swear. All right. So in this problem, it says round to one decimal point. Okay. So when we write the answer, I want to make sure that everybody knows how to round properly. So if I've got 25.6 and I want to round, or 25.63, and I want to round to one decimal point, what should that round to? 25 point what? If I'm rounding to one decimal point. 25.6. So if I'm rounding to one decimal point, I look at the next spot, and if it's 5 or above, I round up. But if it's below 5, I round down. Same thing with rounding to the nearest whole number. Okay? All right. So after we figure out what we need to find and what we know, we need to figure out what equation will fit this. Like, how can we solve for the time? So I want an equation that starts with t, and then on the right side only has displacement, initial velocity, and acceleration. Well, so those are the only things that are allowed to be on the right side. So if I go back to our equation sheet, and remember, Mr. Applewhite was nice enough to do all of the algebra for you guys. So I want an equation that starts with time. So I'm going to circle all the ones that have time in it. So this has time. There's no time in this column. There's time here, and there's time here. Cool. Now, I can only have displacement, initial velocity, and acceleration. Acceleration, displacement, initial velocity, and I'm trying to find time. So anything that has final velocity in any of the equations, I can immediately knock out. So if I look at this equation here, there's no final velocity. I've got A, which is good, displacement, and initial velocities. This one looks good so far. Let's just knock out the other ones just to make sure. So final velocity, we don't have anything about that. So that one's gone. This one also has final velocity. That one's gone too. No, I was going to do a problem with Kadeem. I was going to do a problem with that in a second. Okay, so this is the equation that we're going to use. So it's time equals all that's divided by A. Just to make sure I did it right. Yep. Cool. All right. Everybody understands how I got that this is the actual equation that we're using. Is there any confusion about that? Okay. Wait, did I mark Trinity here? Yeah, she was here. All right. Did James? No, James didn't. All right. So after we figured out which equation that we need, what I'm going to do is everywhere that I've got parenthesis or a variable, I'm going to put parentheses where that variable used to be. Cool. All right, so the value for A was 1 meter per second squared. So I put a 1 there. The distance was 528. So 528. The initial velocity was 15. So both of these were initial velocity. And then the acceleration was 1. Cool. Now, I would recommend doing this in Desmos. But let's kind of simplify it. See if we can make life a little bit easier for ourselves. So the 2 and the 1, we can just put 2 times 528 plus, what's 15 squared? 225. Minus 15 divided by 1 doesn't change anything. Okay, so this is easy enough to put into a calculator. So we've got square root 2 times 528 plus 225. And then outside of that, minus 15. And I get 20.79. And this is for the time. That's going to be in seconds. Now, the question asked to round to the nearest one decimal point. So, if I've got 20.79, what would the answer be if I round to the nearest decimal?
20.8.
Correct, 20.8. So that would be the answer. Cool. So I do this process every single time for each one of the problems. Okay. Can I go over the one that you got wrong? Do you know what the problem was, Hans? Was it one dealing with gravity?
Yeah, it was that one.
Okay. Was it the one with the cat cannon?
Yeah.
Okay. All right. So we'll do that one in a second. Actually, we'll do that. All right. So the hardest one that's on this assignment is the one with the cat cannon. The reason being is that there's going to be a little bit of critical thinking that you need to have to figure out what's going on. So there we go. All right, so hopefully y'all can see this. All right. So, Kadeen, this is a problem that's dealing with the acceleration due to gravity. So this could be applied all but the last part that I'm going to talk about with this problem can be applied to the one that you're talking about. Cool. All right, cool. All right, so what's going on in this problem? I have a cat that's being launched from a cannon with a certain velocity, and I want to make sure that I want to know the amount of time it's going to take for the cat to be launched up and for it to come back down. I want to make sure that I'm able to remove the cannon and then put a big beanbag jet there so the cat can have a safe landing. That's the objective of this problem. Why? Oh, wow. I want to make sure that the cat's safe.
I get it now. I get it why I got it wrong.
Okay. Yeah. So is the wording a little weird? Is that why you didn't catch that?
I just wasn't paying attention to it.
Okay. All right. So does everybody understand the concept of the problem? So the cat's going to be launched up into the air and it's going to come back down. And I want to know how much time do I have from the instant that it leaves the cannon, because then I can move the cannon to the point where it's just about to hit the ground. I want to make sure that it's safe by hitting the beanbag chair. So how much time do I get to swap them out? Okay. So that being said, what am I trying to find?
Time.
Time.
And just randomly stopped working. There we go. It's weird. So don't we have to find distance first? Why would we need to find distance? Like, what's your reasoning behind that?
So like on mine, I got the question right, but I first found distance so that way I could calculate how long it would take for the
For the what?
fall back down for the height, because it would be traveling at
You
two
cut out in
different
the middle of that.
Like I found shit. Oh, shoot. I found the distance that it would, so that way I could calculate how long it would take for it to fall back down.
So, yeah. So read what Hans just wrote. So the amount of time that it takes to go up would be the same amount of time that it takes to come down. Does that make sense? So the amount of time that it takes to go reach the maximum height, that time would just need to be doubled to get the total amount of air time.
Like, I mean,
So your logic is correct. So you could find the maximum height, but that's just doing an extra step that we don't need, because we already know that the amount of time it takes to get up to the max height is going to be the same amount of time as it takes as if I was going to drop something from that height to the ground.
so if you drop something from the same height, it would end up being the same velocity, the final velocity as start velocity, if I were to throw it from the ground to reach that height.
So the initial and the final velocity would be swapped. So if I launched it vertically, the initial velocity would be, in this case, 17 meters per second. If I was launching it
Yeah.
up.
So then when you dropped it, it would be 17 meters per second as the final velocity.
Correct.
Okay, cool.
Yeah. So
I did an extra step for no reason.
Exactly. Yeah. So I wanted to see how many people could actually get this problem, to kind of like to see if they could kind of think about it critically. But it is tripping a lot of people up. So, but that's gonna be later on in the problem. So we need to find the time it takes to go to the top. So the only piece of information that I've given you explicitly is the initial velocity, how fast the cat's being launched out of the tube. Cool. So the initial velocity, v sub I, is 17 meters per second. Cool. And then since we're dealing with something that's going in the vertical axis, like if it's falling or like being shot up, the acceleration due to gravity is always going to be present. And we also know that by definition, the maximum height that something reaches, if it's being launched vertically, the max height is defined as when the velocity of that object reaches zero. So it has an initial velocity, it's traveling upwards, but it's slowing down as it's going up. It reaches zero, and then it switches its sign and becomes a negative velocity and starts speeding up in the negative direction. So at the instant that it reaches a 0 point with the velocity, that is defined as the maximum height. So I know that my final velocity in this case, when it reaches the max height, is going to be 0 meters per second. And then the acceleration due to gravity, little g. In my class, it's going to be negative 10 meters per second squared. That's just in my class, just to make the math easier. All right. So this is probably where people got tripped up. So the acceleration due to gravity is little g, this guy here. But in our equations, we don't have g. Little g is a special case of an acceleration. So we want an equation that starts with time, so t equals, and then on the right side has initial velocity, final velocity, and acceleration. Is that where you're getting tripped up, Kadeem? India, why do you want to leave early?
I got some things to do, and I just need to leave early.
Have you finished your assignment yet?
I will finish it by the end of today.
You better get like at least a 90% on it.
We'll see what I can do.
Make sure if you
Who just did that?
I did. Come at me.
Oh, I was about to say. I am coming at you. Don't be mocking me with the world.
So this is being live streamed to YouTube. So for those of you who have not subscribed to my channel, where's my
Not the vlog.
what?
I said not the vlog.
Like and subscribe. Make sure you hit the bell icon. All right. So that's the link to my YouTube channel. This is where the live stream's going. So you can go back and watch this video. Cool.
Okay. Thank you.
You're welcome. All right. So I want an equation that starts with t and only has v sub I, v sub f, and a. So if I go back to the equations, so solving for the time, so there's time, nothing has time in there. Then time is here and time is here. And I only want an expression that has v sub I, v sub f, and a. V sub I, v sub f, and a. I'm solving for time. Anything that has displacement or distance in it, I can immediately cross out. So that's got displacement. Get rid of it. This one, there's no displacement, so I'm going to leave that be for now. And we got displacement. Yep, that's gone. Okay, so this is the one. Time is equal to final velocity minus the initial velocity times a, or divided by a. So time is equal to final velocity minus initial velocity divided by a. everywhere that I've got variables, put open and close parentheses. Final velocity is 0. So put 0 there. Make sure my face isn't in the way. Initial velocity was 17. And then the time was -10. Any questions about that? So what I end up getting is -17 divided by -10, which is the negative and the negative cancel out. So it's going to be 17 divided by 10, and I get 1.7. That's going to be seconds. This is time. But, like we talked about at the beginning of the problem, that's only for the time going up. So the time going from the cannon to the max height, that's 1.7 seconds. So in order to get the total amount of air time from being launched from the cannon, max height, and then back down, all I have to do is multiply it by 2. 1.7 times 2 is 3.4 seconds. And there's the answer. Cool. So, Kadeem, did that kind of answer your question about acceleration due to gravity?
Indubitably, I think it does. So I'm going to take
Indubitably.
this information that you have given me, I'm going to put it towards the problem, and if I get it wrong, then SOS.
Then SOS.
Wait, no, it's SOL.
Then you would be SOL.
Indeed.
Indubitably. So if you get stuck, you can message me on Remind. Okay.
I shall.
Okay. So does anybody else have any other questions? Anybody else have a particular problem that they want me to kind of help you out with? So I think at least everybody has at least started it. Can't remember if James has started it yet. Everybody good? Okay. So if nobody else has any other questions, I'm going to end the YouTube live stream.